Welcome back to another packet tracer activity. This is 723 and we are testing redundancy in the network design. So we are going to just look at some testing methods for comparing devices and topologies. So we're going to observe our network and then have some links fail and then watch the network recover. So we have our stadium redundancy test plan document that's going to show us how to we'll verify the configuration of EIGRP, then the spanning tree protocol, then we'll do a failure with the switched portion of the network and then in the routed portion and observe both. So back here I've got the test procedures. So the first one is verify configuration of EIGRP, so we can console into a device and ping all the other devices. So we just go to our terminal, and so we've gone into switch 1, and let's ping a few things. We've got our address list up here. Trying to ping our router 1, and that's successful. Router 2 is successful. Let's try PC2 72.18.8.8.10, and that was successful. So you can go through and ping all of them, but it will reach all of them. If we look at the next step, we want to telnet to router 1 and do a show run and a show IP route. So to do that, we're still on PC1. Go to a command prompt, and router 1 was 19172. 18.4.1 and we can do a show run. Just to get all the information on this one. You can see our EIGRP autonomous system number 1 and no auto summary for that one, and we wanted to also do a show IP route, and that shows you what we're connected to, what we're directly connected to, and then what routes are EIGRP. So now we're going to trace the route from PC1 to PC2 to see what path it's taking. So PC2 is 172.18.4.25. What did I type? 18.4. What am I typing? 18.8.10 is what I should be typing. There we go. So now we can see it goes from PC1 into this switch here, and then goes to 4.2, which is router 2, so it's going over here, and then goes to 0.14 and then 0.18, so that's router 3, and then router 4. So it's coming this way, up, 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 into the switch here and over. So it's coming this way. Alright, so now let's look at one of the switches. We can go in with this one again, and we can telnet into switch 1. Which is 172.18.4.3. Do a show run. So you can look at all the settings on that one. You can go ahead and go into switch 2 and switch 3 and get that same info. You can also run the command or show spanning tree VLAN 1. Gives you the information on spanning tree, your root ID, your bridge ID, and all the interfaces that it's connected to that are running spanning tree protocol in there. Alright, so now we're going to simulate a failure on the switched portion. So from the PC here, we are going to ping. We're going to send a bunch of pings to 172.18.4.25, and that's pinging the discovery server. So you can see that starts to go, and we will remove the link between S1 and S3, which is right here. So then we can watch what happens to our ping. You can see the request is timing out now. Spanning tree protocol needs to configure this one and open up this port. So that's what we're waiting for. You can see there that it's finally did it, so it gave us 5 request timeouts before it started sending them all. And now we can telnet back into the switches. And do a show spanning tree VLAN 1. You can say we've lost an interface down here. 0/5 is gone. And you can see we've got, we may have a new root bridge. I have to go check the last one to see what we have. Okay, so the root and the bridge ID are the same, but we have lost one of our interfaces. But there you go, that is the recovery for Spanning Tree Protocol. And now we're going to do a failure in the EIGRP routed network. So we're going to go to PC1 again, and we're going to ping one. We're going to send a bunch of pings to 172.18.8.10, which is PC2. So that's going, and we're going to remove the link between R2 and R3. Which is right here. Remember, this traffic was going up this side. So we've severed that link. And if you can see that, that's right away. It didn't even give us one failure. Like the spanning tree, we had a request timeout 5 times, but this one you couldn't even notice anything going on there, as it might be able to see right here the time for the pings came up to 13, 12, 17, double digits before. Now at the end we're down to 1 millisecond, 2 milliseconds, so that might have been some time that it was switching, but it was much faster. So now we can do a tracert again and see how that's now going into switch 1. Then router 1 is 4.1, 0.6 is router 3, .18 is router 4, 8.10 is the switch, or 8.10 I guess is the PC. So that is the failure on the EIGRP. You can also go into the routers and do show IP route. That's a switch. And now you can see the IP route table is a little smaller, and you can see all the changes in there. If you go through and look at all of them, you'd see some of the routes missing where we took away the links. I guess this is router 1, so this one's going to be the same because we didn't remove any links on it. But that is just observing the redundancy in the Spanning Tree Protocol and applied to a switched network, and then looking at the failure of EIGRP and recovery on a routed network, and the show commands that show you the results of those redundancies. So that is it for this one. Thank you very much for watching.